Hello and welcome to the next edition of the BobCAD-CAM webinar series. Today is stage 2 for 3D Programming Bootcamp. Let's see. The goal of today's webinar is to understand the options you have to rough parts out in 3D. As you know, my name is Al DiPaolo. I'm the voice of the Bobcat After Dark video series. You can find us on Instagram at BobCAD-CAM, or you can follow the hashtag Bobcad or hashtag BobCAM. Now, what are we going to talk about today? Well, we're going to look at roughing out this part in 3D. In the first stage, we talked about importing the geometry, setting up your work holding, getting the general layout of the software going. In today's webinar, we're going to talk about roughing with a 2-axis profile or open pocketing, Z-level rough, advanced roughing, or some of the surface-based toolpaths. Now, as always with BobCAD, you can expect fewer steps, better cuts, and more profit. So why don't you give me just a moment here to set up my screen and we'll get going. Okay, so what I want to do first is go over some of the questions that we had in last week's webinar. One of the questions that came in is, how do I check my geometry boundaries in the CAM tree that I already have? Okay, so with BobCAD, it's a feature-based programming system. So we create a feature that's associated to geometry and contains operations being your toolpath. So if you review any of your features, like this one, you can see it's using a boundary. If I click on that boundary, it will preview what boundary I'm using in the CAD interface, okay? If I click on the geometry, it will preview what geometry I'm using. And if I click on the operation, it will show the operation if it wasn't, if it was hidden previously, okay? So how do I check geometry and boundaries in the CAM tree? You can go over to any feature. If you click on geometry, it will show you what geometry you're working with. And if you click on boundary, it will show you what boundary you're working with. Now, let's see what else we have here. How do I check the geometry and boundaries in the CAM tree that I already have? Okay, I already answered that one. Let's see. How is Z-level rough toolpath contained? Okay, so Z-level rough toolpath is contained based off of the selected geometry and your stock. Okay, so if I go to my stock here and I turn down my transparency, that is my stock material set up for this job. And if we look at our Z-level rough, you're going to notice that the center of the tool, let me unblank this, the center of the tool is going to go right to that boundary. Okay, so if you think about it, if you adjust your boundary, if you adjust your stock, then the tool path will be driven to that as well. So let's go ahead and test this. I'm going to add an inch in X and an inch in Y, and then I'm also going to add an inch in Z. Okay, we'll go ahead and recompute this. It'll take a second to calculate and we'll look at what we got. Now, what we're going to find is the tool path is contained by the stock geometry, but it's also contained by the part geometry. Okay, so the stock geometry is used to control where the tool path is located in X and Y. So in our example, you can see we added more stock in positive X and negative X. So you can see the tool path was extended to match that. Now, we also added additional stock in Z, and some people, including myself, I expected the tool path to go down in Z to where the material is. But what you'll find with Z-level rough is the Z constraints is based off of your selected geometry. So this is the geometry that we've selected. So we're not going to get anything further than the bottom of that geometry. Okay, and the stock, what we're going to find is that the stock is going to control where that tool path is generated in X and Y. Okay. All right, so let's see what else we have. Where is top and bottom of job reference from? Okay, so that's another really good question. So in this case, I've zeroed my job as the top of stock. Here, let me turn my transparency back down. Okay, so in this example, I've zeroed my job, or my machine setup location is at the top center of the part. So when we're using our levels, if we edit this and we say our top of job and bottom of job programming, the question is, where is top and bottom of job referenced from? So this is top and bottom of job, okay? And this is referenced from your setup location, so your 0 location, okay? Or your origin or your work offset. So that's what that one is. Let's see. Can you pocket mill from the outside and climb all the way in? Okay, in this example, on stage 1, we did a Z-level rough. We also did a Z-level finish, and then we did a planer. Those are the tool paths that we used to machine this part. The question is, could you have used a 2D pocket and work your way in from the outside? And the answer is yes, and that's actually one of the tool paths that we'll be discussing here today, okay? So yes, you can use a pocket or even a profile routine to work its way in from the outside. Okay, let's see what else we have. Is there a way to set planer to climb cut from the outside to inside, kind of like a spiral? Okay, so here is our planer cut here. All right, and with the planer cut, what you're going to see is the tool path is going to start on one side. It's going to work its way back and forth, okay, going back and forth, and then working its way across the entire part. What is being asked is, can the tool path work from the outside to the center of the part? And the answer is, with mill standard planer, no. Okay, if you have mill professional, okay, if you're a mill professional user, there's something called equidistant offset that would give you a spiral in from the outside. Or if you're a mill premium user, which I'll show real quick, if we're under, let's say, parallel cuts here, there is some sorting in here where it has cut order. You can see right now it's set to standard. Okay, for mill premium users, parallel cuts is similar to Z-level finish or planer. And one of the options you have in cut order is standard. You have center away, and then you also have outside to center. So if you're a mill premium user, you would have those options. If you're a mill standard user, you would not have those options. Okay, let's see what else we got. Where are cycle times listed? Cycle times are listed in a variety of places, okay? In version 30, you're going to find them under the milling job and toolpath statistics. This will give all the information about the job, the time data, toolpath extents, toolpath data, and the speeds and feeds. And you can go through each feature to see exactly how that was programmed. Okay? All right. If you're not a version 30 user, you can go to your setup sheets. If you go generate setup sheet, you'll find your speeds and feeds and your cycle time estimates for each operation listed there. And if you have BobCAD and you don't have setup sheets, I guess it would also be listed in the simulation. If you go to simulation, there is some reporting tools about the job that would give you cycle time estimates. So either in simulation or with your setup sheets or with your toolpath statistics right from your job. If you're in simulation, if you go under statistics, this will give you all the information about that job and their runtime estimate as well. Okay, very good. Let's see what else we have. Can you select a specific surface instead of the whole geometry to machine instead of a boundary, or select the whole part and exclude one surface? This is another great question. Can you, like if you look at this example, I've selected the entire model, I've selected a boundary, and that's my tool path. So the question is, can you select just some of this surface? So let's remove our boundary, let's remove our geometry, and let's just select on one surface, okay? So the answer is you can just select one surface, okay? Where you're gonna run into issues is the neighboring surfaces, okay? So most of the time, BobCAD's gouge protection. In our 3D toolpaths, we have built-in gouge protection, and it's based upon what you've selected. So if you only select a single surface, that's the only thing the software is going to see. So it can be problematic, especially if you have other surfaces that the tool could run into, okay? So yes, you could just select a single surface, but it could run into problems. Now, if you are a mill professional user, if we go to mill 3-axis and we look at our advanced planer here, one of the options you're going to see in Advanced Planar or many of the 3D Pro toolpaths is what's called gouge checking with check surfaces. And the advantage with this is you could select all of your geometry or just a few surfaces, but more importantly, you could select surfaces to check the toolpath against. Okay, so what do I mean by that? Let's go ahead and finish here. Let's just select all of our geometry. Okay, let's adjust some of our settings here. I'm just gonna loosen up our tolerance. Okay. And we'll compute this toolpath. And what we'll see is the toolpath is going to run back and forth over the entire model. Okay. So using check surfaces, there are a couple of things that we can do. Number one, this bottom shoulder here, let's say that I didn't want the toolpath to touch that surface at all. Okay. You could use a boundary, but you could also use check surfaces. So this is how that works. We'll go gouge check. Check number one, check surface. This is the surface that we want to pay attention to, which is this one right here. Okay. So if you have selected those surfaces, okay, sorry about that. So we've selected the surface that we want to pay attention to. Okay, we are going to lock in that selection. From here, we'll give it an allowance. We'll say, 10 thou here, and then what we're going to do is trim and relink. We'll recompute, and what we'll find is that if the tool comes within that allowance, that tool path will be trimmed away. So you'll see a lot of this tool path is trimmed away. Now, I've only set the tolerance to be a very small number. Okay, if we want to trim more of this tool path away further up, what we could do is either select additional surfaces, or we're going to just adjust this this allowance. Let's make it 1 inch and recompute, and then what that will do is trim out any tool path that is within 1 inch of that surface. It's a very powerful, very useful tool. You're going to find your Mill Pro users use this quite often. Okay. All right. So let's see, what else do we have? What does the machining tolerance do, and why are you loosening it? Okay. So the machining tolerance is, it's an accuracy setting. Okay. And as this is a smaller number, 0.0005, that becomes a very accurate cut. And then as it's a bigger number, 0.001, or whatever number you put in there, becomes much a looser tolerance. So why do I loosen the tolerance? Well, number one, toolpaths calculate quicker. And a lot of times when you're trying to figure out your toolpath, it's better to see what it's doing first before you have it uber high tolerance, because it takes longer to calculate and make changes. So with the machining tolerance, I loosen it to speed things up, but I'll also increase the tolerance as I get ready for final machining. Okay, so that's what it is, and that's what it does. The next question we have here is, can you control the start point and ending point for toolpath? It depends on what toolpath it is really the answer. Most of the toolpaths will give you a starting point direction or side, but many of them will not. So it really just depends on which toolpath you're using. Let's see what else we have. Does the machining tolerance change the cusp height? No, the machining tolerance does not change the cusp height. The step over would change the cusp height. Can some features of this part be cut in 2D? And the answer is absolutely, and that is a lot of what we're going to cover here today. Another question here is, can you draw in 3D with BobCAD? Yes, this entire valve cover here was drawn in BobCAD. I did draw another one in SolidWorks, and that is the one we'll be working with today. But BobCAD is a complete solid modeler, so definitely you can draw in 3D. What is the best way to do an open pocket when all you need to do is go all around? If you don't need to go all the way around the part, you can do a 3-sided open pocket. You could do a 2-sided open pocket or a 1-sided open pocket. So that might work for you. Or in 3D with advanced roughing, you can use operation stock in order to limit where toolpath is going. So that's the Q&A from, let's see, stage 1. So give me just a second to set up my screen here, and then we'll get into today's file and workflow. Okay, All right, so here's today's part. And again, we're looking at how to rough out this part. And there's a lot of different ways in which you can rough out parts in 3D. And I think one of the points that I'm trying to bring up is you can combine both 2D and 3D toolpaths in one job tree. Okay, so this first example here, this is going to use a larger end mill or shell mill. And what we're going to do is just walk the tool around the outside of the part. Okay, this type of toolpath is very easy to set up. There's not a lot of thought process really needs to go into this. You select your geometry and you set your step down and away you go. Okay, so that would be probably the first way a lot of people would consider roughing out the majority of this material, is using the largest tool possible. Now, if we do go to a right view on this, it may be hard to tell, but there is actually a taper on the wall. So one of the drawbacks of using a larger tool like this is you're going to end up having a lot more leftover material. Inside of these reliefs here, this larger tool is going to fit inside of there, so we're going to have leftover material in there. But again, two-axis profiling is a great way in order to remove a lot of material. Now, if I edit this feature for just a second, I did do a standard profile. If you wanted to ramp down as you were going, we could use contour ramping, or if you wanted to take more than one pass in X and Y, we could use side roughing. So two-axis profiling with either a standard profile, contour ramping, or side roughing would do a good job of roughing out this shoulder here. Okay. Now, what's another method that we could use for this? This one's called open pocketing. Open pocketing, we're going to use some geometry. We'll use a dotted line to represent the outside of the stock. We'll use a closed profile to represent where we want to machine to. Open pocketing is another very easy way to come in and to rough out a lot of material. If we go under pocket and patterns, you're going to find this under advanced pocket adaptive roughing. Those are the terminology used within the wizard. Okay, again, for our geometry setup here, we'll use a dotted line that represents the stock edge, or where we want the tool to start outside of, and then we'll use a closed profile of where we want to profile into. Okay, so open pocketing is another really good option for you here. Let's see, Z-level rough. Z-level rough is probably one of the more common tool paths that are used to rough in 3D. Again, we would select our entire model here, and then we can use our stock geometry to constrain the tool path in X and Y. As far as any Z-level constraints, you can come in here under parameters, and you can use top and bottom of the job in order to restrict where that tool path is cutting in 3D. Now, as we move forward from there, this is using the Mill Professional toolpath. This one's called Advanced Rough. With Advanced Rough, you have an offset style, you have a parallel style, and then you also have an adaptive style. So depending on which makes most sense for you, you may use any three of those patterns. If we go into the Advanced Rough and we go under patterns, you have offset, parallel, and adaptive. Okay, the adaptive is very similar to the open pocket routine. As far as the toolpath pattern, what's different is one is a 2D toolpath, which wouldn't accommodate for the tapered walls or any curved surfaces, and the other one is a 3D toolpath, which would accomplish that. You can cut in single direction or bidirectional. You can force the tool to start from the outside of the part so that it doesn't plunge in on any of the material, and that's what you're seeing in this parallel routine. So again, advanced roughing is probably going to be your go-to if you're a Mill premium user. Mill professional user. Now, if you're a Mill premium user, you do get a variety of surface-based toolpaths that you can use. Some of the benefits of the surface-based toolpaths is they do add a lot of control. We do have a roughing tab, and there's a lot of options in which you can use to modify that toolpath to generate different results. Okay, so in our example, what I've done is I've done a surface-based toolpath here, and from there what I did is I have a drive surface, and then I have an edge curve. Let's see. I wonder why it's not showing up here. But I'm using the drive surface, which would be, I believe it's this surface here, and then the edge curve is the edge or the intersection of that surface there. And what I did with this one is I made it into a plunge roughing routine. So what the tool does is it goes down and comes up and goes down and comes up. And this way I'm able to rough out the material, working its way around the part. It does look like I have a side step here that I may or may not want, but again, all of that can be adjusted. If we edit the feature and we go under roughing and we go over plunge, we have a step length and a side length. If I remove this side length here and I recompute, that will get rid of that. I believe that's so that you can back the tool off from the cut so that it doesn't return straight back up. But again, these are just some of the different ways that you can rough in 3D. Again, using a 2-axis profile, using an open pocketing routine, Z-level rough, your advanced rough, or your surface-based toolpaths. Now, I hope you guys have enjoyed today's 3D Bootcamp. If you haven't signed up for the last 2 sessions, go ahead and go to BobCAD.com, go over training and then down to webinars. That's where you can sign up. With BobCAD, you can always expect fewer steps, better cuts, and more profit. I want to thank each and every one of you for watching today's webinar and look forward to seeing you in the next one. Thank you so much.